Good day, folks. Welcome to my YouTube channel. Um, Thank you for watching this video and continue to subscribe and like all my videos till the end. Now we're looking at electrostatics, but in a different angle. Now it says two charges Q1 and Q2 are placed 30 centimeter apart as shown in the diagram below. Point P is 10 centimeter east of Q2. Right, we have Q1 and Q2, and the Q1 here is positive and Q2 is negative there. Now there's a point here. This point experienced the net electric field strength from Q2, Q1 and Q2, right? Now the question, it says define the term electric field at a point. Guys, stick to the exam guideline and that. Now question 7.2, it says calculate the magnitude and direction of the net electric field at point P, right? So guys, one of the important thing that is important here, right, we have a positive, the electric field that is experienced by P due to Q1. The field lines of Q1, since it's positive, are going to go to the right. So the electric field, they're going to be like that. So the electric field strength that is going to be experienced by P, let me draw a free body diagram. The electric field strength that is going to experience by P due to Q1, it's going to go to the right. So we're going to say it's electric field of what? Q1, of 1 on P, right? And then the electric field strength that is going to be experienced by P due to Q2 since it's negative, and then the field lines of Q2 are going to go to the left, right? And due to the distance, the electric field strength that is experienced by P due to Q2, it's going to be bigger because the shorter distance, but for due to Q1, it's going to be smaller due to the bigger distance, right? So here's the electric field that is experienced by P due to Q2. It's gonna go in that direction to the left, right? This is E of Q2 on P, because of the field lines of P are going towards the field lines of P are going of Q2 are going towards like that, so it's gonna go to the left. Even the free body diagram, you're going to have the electric field of what? Of Q2 on P, and then you draw an electric field of Q1 on P. It's gonna go in that direction, and then this is E1, which is Q1 on P, and then the resultant will start from the tail of the first vector to the head of the last vector. So the E net here, the E net's direction is gonna go to the left, right? So it's gonna go to the left. Now let's calculate there. So, and this is 7.2, so we'll calculate the electric field of Q1 on P. Write the formula KQ1 over R squared, and then we substitute K there, and then we substitute Q1, it's 3 microcoulomb, and then the distance between them, it's what? From there to there, it's what? It's 40, but it's 40 centimeter, it has to be meters, so it's 30 plus 10, it's 40, divide by 100 square. So the answer here, when you punch that in the calculator, it will be 1,69 times 10 to the power 5 newtons per coulomb. And what is the direction? The direction there, it's what? It's east, which is it's not east. Yeah, it's east. Q1 and Q2, it's east, which is right. So it's going in that direction, as I've mentioned, right? So which is to the right, in other words. The other words is right. Now let's calculate the electric field of what? Of E2 on P. And then it's 9 times 10 to the power 9. And then the charge of Q2, it's 5 microcoulomb divided by the distance here is what? It's 10. So it's going to be 10 divided by 100 when you convert into meters square. So when you punch that in the calculator, the answer will be 4,5 times 10 to the power 6. Do you see it's bigger than this? As I've mentioned, just like you see here, this is bigger than this. So Newton per coulomb, and the direction is going to the west, or what? Left. Right, but stick to the directions that you're given here, these ones. Right, and when we do a net now, the net is going to be, the net is E net, which is the net we already see there. Its E net is going to be E2 on P, charge 2 on P, and then the second one, it's going to be E1 on P. But it's very important to understand their direction, to punch it with their directions there. So the E2 is going to the left and west. It's very important. So that value, it's negative 4,5 times 10 to the power negative 6, and we can put the negative there. And then plus this one is going to the right, it's going to be positive. So which is going to be 169 times 10 to the power what? Times 10 to the power 5, and then the answer there, it will be negative 4,33 times 10 to the power 5, positive 5, not positive 5, 6 newtons per coulomb. And then that negative, it tells us that it's 4,33 times 10 to the power 6 newtons per coulomb to the what? To the west. That's west, as I've mentioned, that the net is going to the west. Now it says two charges are brought into contact to each other and then placed at their original position. It's very important. Those two charges were separated by the distance of 30 centimeters. So after they transferred the charges to each other, they were brought back to the distance of what? This distance here. It's 30 what? Centimeter. It's very important. Now the question, it says calculate the charge on each particle after in contact. They want the new charge, guys. They get the new charge after they've been in contact. So the Q new there, it's Q1 plus Q2 divided by 2, which is going to be those charges, it's positive 3 and negative 5 microcoulomb, positive 3 and negative 5 microcoulomb. I ignored the microcoulomb, so it's going to be negative 1. But since you know it's microcoulomb, you say times 10 to the power negative 6 at the end, the coulomb. So the new charges now, this one is negatively charged and this one is negatively charged now. Now they say now after Q1 and Q2 are brought into contact, a charge 3 is placed 0.25 meters due to south, which is here's the charge 3. This is charge 1 and charge 2. Charge 1 and charge 2, and they are placed in their original distance after they got to the new charge. They've been contacted and then separated, and the new charge is this one. And now there's a new charge, which is Q3 is 0.25 due to north, due south, man. Now it says Q1 experiences a net force of magnitude of 5.1 due to the other two charges. So this simply means, guys, the force that Q2 exert on Q1 plus the force of Q3 on Q1, the net is that, right? Remember, guys, when you have the forces at an angle, the net force of this one is due to this one and this one, right? But now we are told that net force and that the direction is going in that direction, right? So now what is important here? Okay, now the question is asking the question here, what is the nature of charge 3, charge Q3? What is the nature of it? Okay, now I would like to do this. The net force is going in that direction, right? This is the net force, right? And if the net force is going in that direction, and then the force of Q2 on Q1, since they're both positive, they're new charge, this one is going to repel this one in that direction. So that force is going to go in that direction. So it's a force of what? Of Q2 on Q2 on Q1. I hope that makes sense. And then between these two, okay, generally the free body the force diagram, it has to be like this, the direction, because and if this is your first and then your second, it has to be like that. It can't go down because you are given the net there. The net, it has to be starting from the tail of the first vector to the head of the last vector. So this one, it has to have a head. It has to be a head there. So that means if this force is going upwards, which is the force that this one exerts on this one is going upwards, that means that they're repelling. That means this one, it has to be a like charge with this one, so it pushes it up because this force is going up. So we conclude that the charge here is what? Is negative. The answer there is negative. So this force is a force of what? Of Q3 on Q1. I hope that makes sense, guys, and we have an angle there. So now 7.5, it says calculate the magnitude of Q3. Now to calculate the magnitude of Q3, guys, we have to have the magnitude of the force that they exert on each other, which is the magnitude of the force that they exert on each other, right? Getting that magnitude of the force, which is it's this side, we only have this side. So can we get this side first, and then we have two sides, this and this, and then after getting this side and this side, we can get this side, which is this side. This is the force that occurs between the two, and then we can calculate the magnitude of the charge. So the first thing that we're going to do, we'll find this side, and it's easy. We're given the charge, and we're given the distance there. So the answer when we calculate that, let me start here. I'll say the force of what? It has to be the red one. Force of Q2 on Q1, and then I write the formula Q1 and Q2, R squared. I'm calculating this force, guys, and then it's 9 times 10 to the power 9, and then the charges are like charges, guys. Remember, they are new, they have a new charge, so it's going to be 1 times 10 to the power negative 6 square, because I have these are the same, and then divide by the distance is 30 centimeter square. And if you punch that in the calculator, your answer will be 0.1 newtons. And then what is the direction of that? The direction of Q2 is going to be west or left, because this one repels this one in that direction, this one repels this one in that direction. Okay, now we have this now, and we have that. This we were given, it's 5.1 times 10 to the power negative 1 newtons, and this one we just calculated, it's 0.1 newtons. Now we want this. Why would we want that? To repeat that, if this force is this force that occurs here, so if we want to choose 3, if we have the force there, it will be easy, right? So now I'll do the Pythagoras theorem, because I have this side and this side. I want this side, right? So I'll say F net square is equal to FQ3 on Q1 square plus FQ2 on Q1 square. And then my unknown is this, right? My unknown is that. So let me make it a subject of the formula. So I can say force of Q2 on Q1 square is equal to square root. Okay, let me not put the square here. So I'll just transpose this to this side. So I'll have F net square minus force of Q3 on Q1 square. And then I'll put those forces there. The F net, it's 5.1 times 10 to the power negative 1 square. The force of this, that's not what I'm looking for. I'm looking for, guys, this is my unknown. This is my unknown here. This is my unknown, so I'll transpose this one. I'll transpose this one here. And then this is will be Q3 on 1, and then this is will be Q2 on 1. Yeah, and then the force of Q2 is the one that we just calculated on 1. It's 0.1 square. So if you punch that in the calculator, your answer there, it will be 0.5 newtons, right? Which is this force now. It's this force now. Now that we have this force, I can simply go and say force of Q3 on Q1 is equal to KQ3 times Q1 over R squared. And then I substituted the force there. It's 0.5, and my K, it's 9 times 10 to the power 9. And the Q3 is the one that I want, and the Q1 is 1 times 10 to the power negative 6. We divide by the distance we were given. So I'm using the force here. The distance we were given, it's 0.25 square. So if you do the math there and you cross multiply there doing the math, your Q3 will be 3,47 times 10 to the power negative 6 coulomb. I hope that makes sense, guys. I hope really makes sense.